Welcome. Today we are going to explore the essential building blocks for C programming, the C standard libraries. These libraries provide a wealth of functions that allow us to perform common tasks, saving us time and effort. Let's take a quick look at three fundamental libraries: stdio.h, which provides input and output operations and file handling functions; stdlib.h, offering memory allocation, random number generation, and utility functions. Finally, math.h, for various mathematical operations and common calculations. Let's delve into stdio.h, the standard input or output library. This library is crucial for reading data and writing data, whether to the console or to files. Some key functions include printf and scanf, which handle formatted input and output operations, allowing you to display information to the user and receive input from them. Functions like fopen and fclose enable you to open, create, and close files for reading and writing data. Fgets and foots are used for string input and output, which are useful for dealing with text-based data. Fret and frite are used for binary input and output, allowing you to read and write raw data directly from and to files. Finally, frnf and fscanf give you formatted input and output specifically for files. Here's a simple example. This code snippet demonstrates opening a file named data.txt in read mode, reading its content using fgets into a buffer, and then displaying it on the console using printf. Finally, the file is closed using fclose. Now let's explore stdlib.h, the standard library, which provides a wide range of general-purpose functions. These functions include memory management, conversions, and other utilities. Let's start with memory management. It includes functions such as malloc, calloc, realloc, and free. Malloc is used to allocate a block of memory, calloc allocates memory and clears it, realloc resizes previously allocated memory, and free releases the memory block. Next up are the conversion functions such as atwa and ataf, which convert strings to integers and floating point numbers respectively. Then we have stratol and stratad that convert strings to long integers and double precision floating point numbers. We can also generate random numbers using rand and initializing the random number generator with srand. Last but not the least, we have functions like exit and abort, which terminate the program's execution. Here is a demonstration of dynamic memory allocation. This code allocates memory for 5 integers using malloc, assigns values to them, and then releases the memory using free to avoid memory leaks. Next, we will see the math.h library. The mathematics library offers a rich set of functions for performing mathematical operations and using mathematical constants. This library is essential for scientific and engineering applications. Let's discuss the trigonometric functions. These include functions such as sine, cosine, and tangent, as well as their inverses arcsine, arccosine, and arctangent. Hyperbolic trigonometric functions such as sin, cosh, and tan are also supported. Then we have power and logarithmic functions. These include functions such as pow, which raises a number to a power, and sqrt, which calculates the square root of a number. Exponential functions like exp, logarithms like log and log base 10, as well as rounding functions like ceil, floor, and round are also available. Here is a demonstration of using math.h. This code calculates the square root of 2.0 and then raises 2.0 to the power of 3. Here's a more complex mathematical formula presented using mathml. This shows how math.h could be used in more advanced calculations. Now let's explore string.h and time.h. String.h, the string library, is used for manipulating arrays of characters, which are commonly known as strings in C programming. Some key functions include strlen, which returns the length of a string. strcpy copies one string to another. strcat concatenates or joins two strings. strcmp compares two strings, returning 0 if they're equal, a negative value if the first string is less than the second, and a positive value otherwise. strstr finds the first occurrence of a substring within a string. Next, we have time.h, the time library, which is used for working with date and time information. Its functions include time, which returns the current calendar time. Difftime calculates the difference between two times. Local time converts a time value to the local time structure. Strftime formats a time value as a string, allowing you to customize the output. Clock returns the processor time used by the program. Finally, let's talk about some best practices and tips for effectively using C standard libraries. First, always check the return values from library functions to handle errors appropriately. For example, when opening a file with fopen, ensure that the returned file pointer is not null. If it is, it indicates an error that needs to be handled. Always free dynamically allocated memory to prevent memory leaks. After using memory allocated with malloc or calloc, release it using free, and then set the pointer to null to avoid dangling pointers. Utilize the most efficient library functions for the required task. For example, use memcopy instead of writing a manual loop for copying arrays, as memcopy is often highly optimized. Always refer to the official documentation for detailed information about function parameters, return values, and behavior. On Unix or Linux systems, you can use the man command followed by the function name such as man3printf to view the manual page for printf. For Windows, the MSDN library provides comprehensive documentation. For additional learning, refer to the C Standard Library reference, the GNU C Library documentation, and the classic book, The C Programming Language by Kernighan and Ritchie. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.